Today we're going to talk about some special products when we are multiplying binomials. What do you notice? What do you wonder? What we hope you notice is that there are a number of things that are similar in these questions. First of all, they all have x or something squared. So they're all a bracket with a squared. They're all binomials, so they all have two terms inside the brackets. They all have letters and numbers, but they are in different spots as well. And something that's not different about them is that they have plus and minuses, so it doesn't seem to matter what the sign is in the middle of the two numbers or the two terms. Now, on a separate piece of paper, can you take a few minutes and actually calculate these? So use the techniques that you know now to calculate the answer for each of these. Pause this while you do it, and then click play to reveal the answers. Here are the answers for you. I'll just go through them really quickly. First of all, you should have written each one of them as two binomials side by side, which means you're multiplying. That also means you're using the distributive law. This letter times this letter times that number times that, number times that. We have called this in the past FOIL, first, outside, inside, last. But that's just an acronym. You don't have to use that. You can just simply remember that you're multiplying the first term by each term in the next bracket, and then the second term by each term in the next bracket. And you would get these, and then you have to collect those like terms in the middle, and you would get -6 there. Same idea here. We have a squared, so we write it as two binomials. We use our FOIL, first term times each of the ones in the second term times each of those, and we get our next line, and then you would collect those like terms in the middle to get the 8x. And you do the same thing here, etc. So just double check your answers, make sure that you have the correct answers, and see if you notice any patterns. What you should notice, we would hope, is that there is a pattern here for the first term of each one. So the first term of each one is simply the first term in the original question squared. So you can always get that. The second thing that we hope you notice is that the last term in each one is simply the last term in the original question squared. And you'll notice that all of them end up being a positive. See the positives in each one of these? They're all positive because when you square a positive or a negative, so a negative times a negative is a positive, and a positive times a negative is also a positive. So it shouldn't make any difference whether it's positive or negative in there. The tricky thing that we're hoping that you notice is that that middle term is made up of the first term times the last term times 2. So if you did -3 times the x times 2, you would get -6x. Same here, if you did the x here times the 4 times 2, you would get 8x. If you did x times -2 times 2, you would get -4. If you did x times y times 2, you would get 2x squared, or sorry, 2xy. And then if you did the 2 times the -y times 2, you would get the -4x. So there's a pattern here, and this pattern has a special name. It is called perfect square trinomials. So basically, you're going to take the first term, whatever that is, and square it to get the first term. You're going to take the last term and square it to get the last term. And then in order to get that middle term, you do 2 times the first term times the last term. So what we want you to do is try to use that pattern to complete these questions. So here's 6 questions. Try not to do the middle steps of each one. We are hoping that this pattern will help you to do these types of questions more efficiently, more quickly, so that you don't have a lot of steps in between. So pause this, take a few minutes and do them, and then push play to reveal the answers. And here are the answers, so you can just double check, make sure that each one you didn't have to do the extra steps in between, that you have the first term squared, the last term squared, and the middle term is 2 times that times that. And remember that all of your last terms should be positive, so double check that they're all positive. And that your first term should always be the square of the first term. And the middle term is always 2 times the first term and the second term. So I'm just going to look at number 3 here and make sure that you understood how to get that middle term. So that middle term would be 2x times -4 times 2. So 2 times -4 is -8, times 2 is -16, and then you have the x. So that's how you would get that one. For number 4 here, again, just to review that how you do this, you have a 1 in front of here, so you have 1x squared times, that's a times sign, not an x, so 1x squared times 3y times 2. So you're going to do the numbers first. So 1 times 3 times 2 is 6. And then x squared times y would give me my x squared y there. Then we look at number 5. Number 5, again, to get that middle term, we would do 3x times -2y. So 3x times, I'll use a dot this time, -2y times 2. So we would get 3 times -2 times 2, so that's -6 times 2 is -12, and then we still have our x and y, so that's how we get that xy. And then the same thing for the end. This one's a little trickier. That front term, remember, the whole thing is squared in order to get that first term. So what we are doing there is 5x squared. All of it is squared. So if you remember back in the past, you would have applied that squared on the outside to both things on the inside. So 5 squared, as well as x squared squared, which gives me 5 times 5 is 25, and x squared is x to the 4. And then that same idea would apply to the 3y squared. You would do 3 times 3 and y squared times y squared. So that would give me my 9y to the 4. And then that middle term would be a combination of the two. So we would get 5x squared, times 3y squared times 2. And 5 times 3 is 15 times 2 is 30, and then x squared and y squared. So that gets me my 30x squared y squared. Now on to the second pattern that we want to cover today. What do you notice? What do you wonder? What we are hoping you will notice here is, once again, we have 2 binomials that we are multiplying for each of these questions. So there's 2 binomials each time. And you will also notice in this question that all the terms inside are identical. So we've got an x there, an x there, a 2 there, and a 2 there. The only difference is that the signs are opposite of each other. So in each of these questions, you will see that occur. This one has an x, x, 3, 3, and a positive negative. This one has an x, x, 4, 4, positive negative. And you could continue that pattern even when we get letters down here like the last one, x squared, y squared, y squared, positive, negative. So it doesn't matter if it's a number or a variable or even a variable squared, as long as they're identical terms with inside the brackets and a positive and negative, that's the type of question we are looking at for some patterns today. So now take a minute and pull out a separate piece of paper and actually multiply these through. Do all the steps in between and see if you can notice and describe any patterns. Pause it now, try the questions, and then push play to reveal the answers. And here are the answers. Double check yours, pause it now, and check your solutions. So the patterns that we are hoping you will notice in these types of questions is that your first term in your final answer is simply the first term in each of the binomials squared. The last term in the answer, which is this one, is simply the last term squared. And then the sign in all of these answers is always negative. And that's because in each of these questions, you will always have a positive times a negative or a negative times a positive. It doesn't really matter which order it's in. But as long as there's one negative and one positive, you are always going to get these two terms in the middle that have basically the exact same terms, but opposite signs. And what that means is that they will cancel out. They essentially disappear, and we end up with x squared minus 4. So they cancel out. They end up being 0. Let's look at the second example just to see if you can see that pattern again. We take the first term and we square it to get the first term in the answer. We take the second term and we square that. So 3 times 3 gives me the 9. And then a positive times a negative will always give me that negative in the middle. And if we do that, I'm just going to skip down to the middle one on the bottom row. It doesn't matter if we have the numbers or the letters first. Again, that first term is going to be the first term in each bracket squared. The last term is going to be that last term in each bracket squared. And then the middle is always going to be a 0 because we have that positive times the negative. And again, it doesn't matter if the first bracket had the negative here instead and then this one was positive, as long as one of them is positive and one of them is negative. And then I put a final example here of the ones with just variables. So again, just following the same pattern, you recognize that the terms are identical in the brackets, and one bracket has a positive and one has a negative. So you would just take the first term in each one and square it. So x squared times x squared, which give me x to the 4. The last term in each bracket, which is y squared times y squared, which gives me y to the 4. And then a positive times a negative gives me a negative. These answers are all referred to as something called difference of squares, and there is a general pattern, and that's going to help us to be able to factor as well in the future. So a difference of squares in general is just when we have the same terms inside the brackets with a positive and a negative inside each of the binomials. So one could be positive and the second one could be negative, or vice versa. You could have a negative and a positive, but you have to have different signs. And generally what that means is that when you do the steps in between, the two middle terms would end up equaling 0, and would disappear from your answer because they would be 0 times whatever the first and second terms are. And your final answer is always the first term squared and the second term squared with a negative in the middle. Now what we're going to do is use this pattern in order to do some of the questions and try to not do those middle steps. So here's some questions to practice. Pause this right now and try these questions and then push play to reveal the answers. Here are the answers. Again, I hope that you quickly have recognized the patterns here. You take the first term in each one, square it. The second term in each one, square it. So 5 times 5 is 25, and a negative and a positive is a negative. All of your final answers should have a negative in them. First term squared is 9. Second term squared is x squared with a negative in the middle because a positive times a negative is a negative. And then I'm just going to skip down to number 5 just for something a little different. You take the first term, square it, the second term, square it, and then put the negative in the middle. Proper form is probably to rearrange those. So you get y to the 4 minus 4. Usually we put it in decreasing order of degree. And if they're the same degree, then we put it alphabetical. But I wanted to leave it in this form originally just so you could see the final answer. And then number 6, you kind of combine those concepts with the letters and the variables. So you're just taking the first term and squaring it. So 3x squared times 3x squared, which give me 9x to the 4. Then 5x squared times 5x squared, which gives me 25x to the 4. And then a positive times a negative, which is a negative. So these are called difference of squares. We would like you to use the 2 patterns that you've learned today in order to do the homework tonight. See if you can not do all the steps in between and use these patterns to make your work quick and more efficient. So here is your work for today.